Welcome to the Rim Break Rodeo. We hope this video helps.
This video shows how to use Yolov5 for object detection step by step. First, prepare your environment with Python 3.8 and pip package manager installed. Clone the Ultralytics repository and install requirements using pip install r requirements. TXT. Download pre-trained weights like Yolov5's, PT, or train from scratch with your dataset. Organize data in a dataset. YAML with train and val paths and number of classes. Run training with Python train. PyImg 640, batch 16 epochs 50 data dataset. YAML. Monitor results with TensorBoard and validate using the val set metrics. Label images using label img or roboflow and export annotations in YOLO format. Structure labels so each line contains class ID x center y center width height normalized. Use data augmentation like mosaic, HSV gains, random scale, and horizontal flip. Adjust hyperparameters in HIP. YAML for learning rate, momentum, weight decay, and augment strength. Fine-tune from Yolov5's PT when you have limited data to speed convergence. Resume interrupted runs with resume and save best weights to run/train/exp**weights. Evaluate with Python val. PyWeights runs/train/exp/weights/best. PT data dataset. YAML img 640. Run inference with Python detect. PyWeights runs/train/exp/weights/best. PT img 640 comp 0. 25. Set source to images, video files, folders, or a webcam index like 0. Export models to ONGX, TorchScript, Core ML, TensorRT, or OpenVINO for deployment. Optimize speed by reducing image size to 320 and using half precision. Apply NMS and set I/O threshold to 0. 45 to remove duplicate detections reliably. Quantize with 8-bit post-training tools to reduce model size and improve latency. Deploy containers or torch serve and test on GPU, then fall back to CPU when needed.
Thanks for watching. Consider subscribing if we helped you.